Before starting, shout out to my chemistry teacher, Mr. Val, and while I'm recording this in class, I have Jad and whoever can SE, if you're watching this, shout out to you, thank you. It's the last day of school, you have free. This is 9.3 chemistry. It's about reaction rates. Which of the following factors increase the rate of a chemical reaction? Always increasing the concentration of reactants, increasing the temperature, increasing the surface area, and addition of catalyst. If they put for you increasing pressure, you don't choose it because they said solid and a liquid, It only works for increasing the pressure if it's a gas, And that came in, I think, the AMS, so you can't put that. Question 2. What increases the number of collisions per second? It's the same question. Decreasing the concentration, obviously not. Increasing the volume, occupied by mixture of gases. Increasing the volume decreases the rate, Remember that C equals N over V. So when you increase the denominator, the concentration will decrease, and obviously if you decrease concentration, then the rate will decrease. Increasing the area of contact, obviously if there's an increased area and an increased surface area, that increases the rate. Then decreasing the temperature, obviously decreasing temperature, less kinetic energy, less collisions. Increasing the concentration of reactants, we said that's correct. Easy. Question 3, what is represented by the above diagram? Over here, you have these particles, and then they started moving. So obviously, they increase the kinetic energy. What causes an increase in kinetic energy? Obviously increasing the temperature. Increase in temperature, increase in average kinetic energy. Question 4. Which of the following affect the rate of a chemical reaction? Again, same question. Temperature, surface area, concentration. Concentration of the product, makhas, and color of the reactant. This one was in the AMS quiz. You have this reaction, and there's this cross over here. So you're going to look down and you're going to wait for the cross to disappear. We're just going to go to the questions. Why do you have to keep the total volume the same? So why is the total volume here 55, 55, 55, 55? Obviously, so it's a fair comparison. It wouldn't be fair if you used 20 here and then 40 here. So for fair comparison. If the reaction is repeated at 40 degrees Celsius, what's going to happen to the temperature, to the rate? Obviously, it's going to increase. As we're doing it now at 20 degrees Celsius. So if you're increasing the temperature, it's going to increase the rate. Maybe here they put for you 60 and then now they put for you 40, that's decreasing, so it's going to decrease the rate. So be careful for that, because the particles obviously move faster, thus the collisions increase. Why would the cross disappear? Over here we have the sulfur precipitate forming. So this sulfur is going to block the cross, so you won't be able to see it anymore. If the experiment is repeated using a bigger beaker, 250 centimeter cube, the time would be longer. Why? Because it's a bigger beaker, thus the time for the precipitate to spread out would be longer. It has there's a larger volume for it to occupy, so that means the time will be longer. It's going to take longer to spread. Here you have question 5 and question 6. Question 6, dilute hydrochloric acid, whatever, cotton wool, blah 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 blah. What is the role of cotton wool? This came in the AMS. I think the question was wrong. It was wrong, right? Yeah. So the question was wrong. So the role of cotton wool is to allow the gas to escape, because the gas will fit through this cotton wool. And also you're going to have splashes in this reaction down here, and the cotton wool prevent the splashes from going out. That's pretty much it. It allows the gas to escape and it prevents the splashing of the acid. What is being released here? Obviously, it's carbon dioxide, hydrochloric acid, HCl, and calcium carbonate, CaCO3. It's going to produce carbon dioxide gas, If it was repeated at 50 degrees Celsius, here it was at 25. If you're increasing the temperature, then the rate of reaction is going to increase. But people are going to put this one here. I don't know why. The initial reaction is going down. What happens? The rate will be faster, so it's going to go down faster. So you're going to choose this one, and they're going to end up at the same point. Always remember, we didn't increase the mass of the limiting or anything. Well, here it's the mass of the stuff in the flask, so it's just the reactants. Don't choose. If it comes in the exam, just choose the one where they meet at the same point. Question 7. 3. in 3 different experiments, equal masses of calcium carbonate were reacted with the same volume of hydrochloric acid. Okay, calcium carbonate is the excess. Okay, pay attention to that. Choose the curve associated with each of the following conditions. Okay, a lower temperature, obviously a lower temperature, it wouldn't change the amount of product formed, but it would only change the rate, make it slower, right? بعدين a lower concentration of hydrochloric acid. Hydrochloric acid isn't the excess of limiting, it's the limiting. Okay, so if you're decreasing the amount of the limiting, what's going to happen? Obviously, there's going to be less product formed. C. Okay, using lumps rather than powdered calcium carbonate. Using lumps would decrease surface area. Okay, and if it's a decrease in surface area, then obviously the rate will decrease. فبتروح على graphs. Okay, which one has a slower rate? B. Then part D, the addition of the catalyst. Obviously, the addition of the catalyst would make it go faster. It's gonna be graph A. Okay. Okay, based on the collision theory, a decrease in the temperature decreases the rate, obviously, because there will be less collisions because lower kinetic energy, blah, blah, blah. Okay, okay, this one wasn't in the AMS quiz, and I think they're going to bring a question like this. You have a reaction like this, and there's 2 steps, okay? They told it's a 2-step process. Step 1 is NO2 plus NO2 to produce NO3 and NO. NO3 plus CO to produce NO2 plus CO2. You have to read the question. Please read the question. The studies show that if you increase the concentration of CO, it will have no effect on the rate. But if you increase that of NO2, it will change the rate of the reaction. So that means one of these reactions are the rate determining step. The rate determining step basically is the one that determines the rate of the whole reaction. Okay? How do I know which one it is? They told me increasing NO2 will increase the rate. So which one has NO2? It's going to be this one here. So that means step 1 is the rate determining step. Okay? It's called, the slowest step is step 1, and it's called the rate determining step. Usually the rate determining step is the slowest one. Okay? Question 10. They gave you a graph, the point X at 7, okay, here at 7.5 seconds, it's not on the line, obviously, because it's a wrong reading. What volume of oxygen is collected after 10 seconds? So you go to 10 seconds, and you go, it's over here, 15, yeah? How long does it take to collect 19 centimeters cube? You go to 19 centimeters over here, you go to the graph, it's over here, 15. Then what causes the reaction to stop? Obviously, when does it stop? If there's no more reactants. Okay, reactants are totally consumed. That's it, question 11. A student added 12 grams of powdered CaCO3 to 1 molar acetic acid solution. Okay, and the acetic acid, they said, is excess. Okay, at 80 degrees Celsius, lower carbon dioxide was produced and collected in a syringe. Okay, what will happen? They gave us 3 grams. If you increase the concentration of the acid is the excess. If you increase the concentration of the acid, will it change the product form? No, right? If our original one's B, what's going to happen? It's just going to become faster. No more extra product will be formed, so it's just going to be C. Okay, because it's the excess, we're increasing the excess. Okay, 15 grams of powdered CaCO3. Now we increase the mass of what? This is the limiting. Calcium carbonate is the limiting. Okay, if you increase the amount of the limiting, then again you're going to have more product formed. So again it's going to be graph D. Okay. The acid was cooled before the reaction. Obviously, if it's cooled, lower temperature, lower kinetic energy, lower rate. It's going to be easy. Okay. Question 12. Same concept. Yeah. At 2 minutes, what minutes does the result appear to be inaccurate? It's inaccurate when it's not on the graph. Okay. So here, where is it? At 2 minutes. Okay. During the first 6 minutes, the speed of the reaction decreased. This came in the end. Okay. When you look at it here, obviously the rate of the reaction is decreasing as you move on because the concentration of the products is decreasing. Okay, so you're going to say the rate of the reaction decreases as you move on. And then in the AMS they asked you an extra part. They said after 6 minutes. Okay, after 6 minutes, what happens to the rate of reaction? You say it becomes 0. You don't say it becomes constant. You say it becomes 0 because khalas, it's not increasing at all. It's staying straight. Most people got this wrong last week in the AMS. As time passes, the initial concentration of hydrochloric acid decreases, obviously, because it's being used up. Thus, the frequency of collisions, obviously, is going to decrease. Okay? Select the graph that would be okay if it was repeated at 50 degrees Celsius. Knowing the original experiment is drawn in black. Okay? 50 degrees Celsius, we start at 25. Your increasing temperature should be same. Obviously, if you increase the temperature, you're going to have a faster rate of reaction. For which one's going to be? It's going to be this one. Why is it not this one? Because this is under. Why is it not this one? It's because they don't have the final the same final point. You see this one's here and this one's up here. Okay? How do you measure the gas? Obviously gas surface. Okay, then here, question 13. The following apparatus is used to prepare oxygen. You have hydrogen peroxide and you have the manganese oxide thing. Okay? For now, manganese oxide is a catalyst. Okay? When working with catalysts, you can't allow the catalyst to mix with the solution. Why? Because we don't want a reaction. So here, the tube of manganese oxide is in the flask. Why? Because we want to prevent the reaction between manganese and hydrogen peroxide. It can do its job by just being in the flask. Its only job is the catalyst, not to react with it. Okay? The reaction starts when the Kaufman string is released. Okay? We release the Kaufman string, the air starts flowing inside, and then we can start reacting. Okay? Manganese oxide is obviously a catalyst. When you use lumps, obviously the rate of reaction is going to decrease because the lumps have a smaller surface area. And when does it stop? When you run out of the reactant, and our reactant here is hydrogen peroxide. So it stops when hydrogen peroxide completely decomposes. Okay? Question 14. It's the last one. There is danger of explosion when a large amount of dry powder combustible material is produced, because if it's so much powder, it's a very high surface area. If the reaction rate might be so fast, it could cause an explosion. And then when concentration increases, obviously frequency increases, collision increases. This leads to an increased reaction rate. Thank you for watching.